Now, this morning we stopped at these slides where we start to look at Miller indexes on the plane. So again, there's a presentation of position and all this. So I write on the whiteboard. So if you are having position, there's a comma. You have x direction, x position, z direction. Then a bracket with without the comma. This is position. Without the comma is plane. Then there is a bracket. Right? Bracket is a direction. Okay. Direction also without the comma, and the negative sign is above the numbers. Okay. And position is negative in front of numbers. Plane also same. Plane also same. If you're negative means the above the number you have a negative sign there. And then there's a family. Family, you use a curly numbers, also without commas. Right, this is family. So be careful on the way you write. Either it's position, plane, direction, or families. Right. So let's look at the first diagram. So the first diagram, if it's you're seeing bracket 100 means the plane is along the x-axis. Okay, means 100 means the plane move 1 unit from the origin. It's like a glass that move 1 unit from the x-axis. Okay, then for the B is that if the plane give you 110, it means the plane move 1 unit to x and also move 1 unit to y. So it will be 45 degree slanted from x to be like that. So 1 unit, 1 unit. Okay, 1 unit to x, 1 unit to y. So it is in a diagonal shape of 110. Then if it's 45 degree from all the axes, for example, the third one, 111 bracket means x move in 1 unit, y move in 1 unit, and z move in 1 unit. So you have x means you mark the x, mark the y, mark the z. You combine the 3 points, it become a plane. It's like how you sit the plane on the axis. Okay. So or another way of seeing it is that when you see 0, you can see it as an infinity value. So it's like you're holding a plane. So when you 100, you mark 1 at the x-axis and then the rest 0, right? So it means infinity. So y infinity, z infinity. So it's like a wall on the x-axis. So same with the second one, right? You mark x, you mark y, then z is infinity. You have a wall, stop at x, stop at y, and then infinity wall. Okay, right. So yeah, the rest you read is the same like what I explained just now. So the rest you read from the slides. Okay. Right. So far everything okay? Right. Okay. Right. Sign your attendance. Those. Okay. Right. The next one is explanation on the Miller's indexes. So it's basically if you see the word Miller, they're referring to plane. They are referring to plane that you are going to draw. Now, what is the purpose of learning Miller indexes? Miller indexes is like you're taking a blade, and then you chop the cube. Then you see what is the shape of the sphere that you have. Right? So we have basic cube, we have BCC, we have FCC, and we have HCP. So BCC, we have 4 sphere on the top, 4 sphere at the back. So it depends on how you slide it. Then you will see different presentation. It's like chopping a watermelon. Okay. So by giving you a Miller indexes means you take your knife and chop according to that direction. Right. So let's see this one. So this one, if you are given the distance from each this one, or maybe you are given straight away the Miller indexes, you should able to plot the chopping board or the plane on the axis. Okay, so for example, this one 632. 632, you can straight away use the full number if you want, but you'll require a bigger numbers rather than using the usually the Miller. This will be 1, this one will be 1. Okay, the numbers that you use on the axis will be 1 for each of the axis. So you need to convert the Miller numbers into how many parts of it in one units. Right? So for example, the first one, 632, you find the minimum minimum number that you can find, right? So you can use 1 divide by 6. You can get 6 divided by 6, so 1 half and 1/3, right? So it depends on how you see it. Okay. So if you're given 1/3, 2/3, and 1, you just multiply by 6. You can just multiply by 6 if you want. Okay. So the steps are the step of, if you are given the so-called the coordinate, right? If you're given x, if you're given this one, it gives you in a cubic plane without giving you this one. It say the cubic crystal plane shown in the figure, and you're given the intercept of 1/3, 2/3, and 1. Means you're given this one, and the height. Okay. So if this kind of question come out, you won't see the number here. It will just show you, maybe it not even show you the diagram. It will give you this statement. Your step expected is you draw the cube and then put inside the intercept. You draw 1/3, you draw 2/3 or y, and then z is 1, means from here to here is 1. Okay. Then how you find these 632 numbers? The second step, once you draw the diagram from the intercept, you do reciprocals, mean you inverted all the numbers. This one you inverted, you get 3. This one you inverted, you get 3/2. This one you inverted, you still get 1. Huh? Huh? Why 1? Oh, it's a step, it's a mathematic steps. It's the easier steps. Okay, let's see. Let's see. Then you'll see why we do it. So we do the reciprocal. We convert it. So we don't allow to use this one. So once you inverted it, you multiply by 2, you'll get 632. Okay. Now you can ignore the reciprocal if you want. Okay. But this is the trick, the fast trick lah. So there's a fast trick where straight away from the interception, you inverted, then you kill all the fraction, then you get the Miller indexes. Of course, you can slowly adjust, like, okay, this is over 1/3, 1/3, and then how you convert into plane. You have to imagine this one become the full length, then this one become full length, and so on. Right? So this is you can try your way of without using reciprocal, but this is a shortcut. Right? This is what I propose. So if you think that reciprocal is very troublesome for you, then you can use your own method. Right? So there's a way of converting all these points into a plane. Right? Yeah. Okay, so this is how you do it lah. This is how you do it. Of course, if you have a better way of doing it, let me know. If you intend to use your own way of finding this one, come to see me first. Don't use your method without discussing with me. Then you write your answer. I might give you wrong because I have no time to check for all this. I will just follow my rubrics. Then I'll give you wrong. So if you have your own way, come and discuss with me. That okay, sir, I'm going to use this method, can or not. So once you show me, then I say, okay, it makes sense. Then you can use your way. Okay. All right. Okay, the rest you read. The rest you read. Okay. So same, the Miller plane here also you can write in a family form. If you are moving one unit from the axis, you also can form notation of curly bracket 100. Okay. So curly bracket, it can be for the plane, it can be for the position and direction. So you need to look carefully what does it fall into. Okay. So this was another example that normally when we do analysis for material, because we like to chop the material the certain angle, because when we study about crystal material, there's a certain way of chopping it or cutting it better. It will break more easily. Okay. So for example, this is the plane. So this is 0, 0, 1, mean x infinity, y infinity, and z you move 1 unit. So from the reference point here, this is so this is you move 1 like that. Okay. And this is slanted one, 110. This one is 111. So it's a 45 degree from the chopping plane. Now, the next one, we see the application of the Miller planes. So for example, we are given a material and it was in the crystalline structure, means repeated pattern. And then when you chop it with 110 plane, 110 means x over here, x at another side. Then you chop at 110 means the front plane here. This is a 110 plane. So another one is here. So another one, if you be a section of 110 plane, 110 plane means you chop 110 like that. You chop like that. Okay. Now 110 is like that. You chop like that. Okay. You chop like that. So when you chop, you look at the plane. What do you see from the cross section? Okay. When you chop, you will see material something like that lah. Sphere, sphere, sphere. Again, this is one, and then if you combine the another half, you get a cube. You will get a cube. Okay. And earlier we already defined, if you're having a BCC, this is a BCC, the A and R will be square root of 2A. Okay, we already defined earlier how to find this one already. Okay, let's look at example 5 and check whether you understand what is position, what is plane, what is direction, and so on. So draw the following plane in the cubic cell. So the first one, 101. Are you able to draw? What do you think? So how should it look like? So you draw the box first. Draw the box. So 1, y is infinity, z is 1. Okay. Try to see. So the first one is like inverted lah, from what you see just now. Okay, second one is 1 minus 0, means you have a go back to the cube. Another side, then 211. Okay, 211. So you want easier? Just now got 3 steps, right? You're given indexes you flip the number and then you make full number. Now you reverse the steps. If you want to find the exact point on the cube, you reverse the step. How you reverse that? You take this one, this is a plane, right? So you reverse that. You reverse means you invert the thing. Then this one, no matter how you invert, you still get the point there. Here, this one you can do the invert. You flip the thing, become 1/2, 1/2, 1. Right? Okay, the first one. So it will look like this. Okay, because it's 1, infinity, 1. You flip the thing, you reciprocal back, you get the 3 point there. So your y is infinity. Y is infinity. X is 1, Z is 1. Then you combine, you draw a line between X and Z. Your y is infinity. You move infinity on both sides. Okay, but you're seeing it in the cube. You're seeing in the cube. Second one, 1 minus 0 means your y is negative, means it's go down. Right? So the rest you do in your own revision. I'll just show you. So in this case, you draw your axis, your origin. Because your x is 1, you move 1, mark 1 here. Your y is negative, so go to the left. Your y is on positive to the right. So your y negative means move back 1. You draw a line. Once you see 0 means infinity. It's like there's another wall, infinity in z direction. So once you join this one, and then infinity, you move up or move down. Same. Okay. So this is how you draw the diagram. And this kind of question is very popular for test 1. It's a way we help you to score very high in the test 1 and test 2. This is the way we help you. So if you don't understand this one, you miss the window of scoring high marks. It's very easy to give mark 1. It depends. For example, this question, I can easily like this one, I give you 3 marks if you complete this one. The whole question you can complete like, I can give you maybe one question like 5 example. 5 is already like maybe 15 or 25. The more complex is it, more means is more marks. Important is that you give me the location. You can write this one 1, this one 1, then you draw the things. Okay. So it can be very easy to score one, this kind of question. Right. All right. Now 112, you just reverse it back. Then you mark the numbers. When you reverse, it become 1/2, 1/2, 1. So x is 1/2, you mark 1/2, y 1/2, z is 1. So you are connecting these 3 line, 3 point, you get the plane. Yes. First, you draw the cube first. You draw the cube, then you draw the origin at the corner at the back. Once you have this one, then you draw your x or draw your y, where is that? Then you look at the Miller plane number. Then you flip the number. 2 become 1/2. Right? Then 1 you flip, you still divided by 1. So you become half 1. So these are the coordinate, or we call it intercept on the axis. This one very easy to score, so don't miss it. Divide 2? No, you flip, because how you get 2? 2 is 2 divided by 1, equal 2. So you flip, what you get? 1/2. Yeah. And divide 2 means yes, it's a wrong answer already. Because it is, if you do 1/2 and you try to plot on the cubic, it won't be in that shape. So here is 1, y, this is x, this is y, this is 1, then this is only half. So you are getting a shallower plane. You are chopping at the lower angle. So it's a wrong procedure. You can only divide half in the position, not in the Miller plane, not in here. Huh? You can only do half for the position. You can only like complete the fraction number here or here direction, but cannot do it formula. Huh? Okay. The third one, he asks you to draw 110 plane in a BCC atomic size. What is BCC? Body-centered cubic, and list the position coordinate of the atom whose centered are intersect with the plane. So you need to draw the cube. And then what is BCC? BCC at the center. And then 4 there. Then you slide the thing 110. 110 means 1, 1, and then half lah. So it means you chop the thing diagonal like that. Then it asks you list of position coordinate of the atom whose centered are intersect by this plane. Show you the workout. So atom position centered are intersect by this plane are all this. So you have one atom here. So it's over here. You have one atom here. You have one atom at the center. Right? Then you have one atom here, one atom here. So here is 1, 1 is 1, 1 is 1. Okay, so these are the coordinate that slide by this plane. So we ask you to list out the position coordinate of the atoms whose centered are intersect by this one. So these are the indexes. So these are the position if you slide. So body centered means you have 1, 2, 3, 4, one sphere at the center, then 1, 2, 3, 4 at the bottom. But in this case, you slide in 110 plane. So you're actually seeing this 5 sphere. So these are the coordinate. For example, the first coordinate is 110. But again, remember the presentation of the coordinate is must come with the comma. Okay, it must come with the corner. So 100 is this one. 101 is this one. 101 is this one. 101 011 011 is here. This one. Okay, and half is this one. This one, 110. Is it correct? Oh, this one. Okay. All right. So basically, it's the idea like that. So if we recycle the question, we ask you another plane, you should able to answer. Okay. Yes, 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 yes. It's a BCC. So you have to prove that actually at that location. The sphere. We are actually using sphere to represent the dot lah, one dot like that lah. But you must like highlight the thing lah. It must be able to see that actually there is a sphere there lah. The size of that. You can draw a big one also, but small one is enough already. Can. Right. Okay. So another thing is that relationship on that one. So there is a way of doing calculation now on the diameter of HK and L. So HK and L, they are indexes in the plane. So this one, the Miller indexes. This one is HK and L. HK and L. So now there's a calculation here. So this one, you look at the top, and then you slide the thing. You look at the top of the cube, then you slide the plane. Okay, for example, plane of 110, plane of 110 also. because it's in the same family. So you move in one unit. Okay, one unit. So there are 3 planes, for example. Right, for example. So if you slide the things, then you have a distance 110. D110 means HK and L. Right, HK and L. So the distance is OB, is OB or AB, or BC will be the same. So this is more on the application of the Miller index. Okay, so the rest is from the table, from this diagram. Okay. So to find the D, it's actually a trigonometry equation. So how you find this D? You see that there's a triangular here, right? Triangular here. So this one, here also 90 degree. So it's a trigonometry equation. D and A. So this 90 degree. So this is what? This is how much is this one? This one is D A.
Down there.
Okay. HJK is your plane. Is your plane numbers here. 110 means H is 1, K is 1, L is 0.
So it's like X, Y, Z.
So this one you plug in the numbers and you
can write X, Y, Z
you might be confused because when you write X, Y, Z, you might confuse with the position, direction, and so on. So this is more on the plane itself. That's why you use another symbol for that. Okay. So the rest you read. Okay. All right. So we see one example on that. So he asks you to determine the Miller indexes of the cube, as you see here. So you're given a cube and you're given a plane cut in this direction. So x is here. No, y. You're given a z. So x basically is infinity. So infinity is 0, right? Means it like this. It go this way, This way is infinity, This is y, Your x is actually like along this side. So it is 0. So then z is it z? No. Y you have 2 direction, right? Y. Okay, y you got 2. So this is a bit challenging. Okay, so the step will be like this. Okay, so it will start to calculate the distance between the balance here and then the balance over there. You transpose to a one corner. You transfer the whole this one. So that you get a full number at one corner, right? You can shift to the left or right, but in this case, because the distance is a bit shorter here, so we shift it to the this one. So we shift it so that this plane is shifted to the new position, but the plane orientation is still the same. So here you get the distance when you shift, right? This one you shift 1 over a quarter, right? This one you shift 1/4. So the total distance from here to here is 1/3 plus 1/4 minus 1, right? Or 2/3 minus the quarter. You get the distance here. Make sense? Make sense, huh? Okay. Now from there, you have a new intercept of this is intercept, comma means position, right? So 1, negative 1/5. 1 is because this one it moved 1. move 1. So this is 1. So y is move here. So x is 1, then y move no new origin is
But why is the origin of the right?
okay, hold on. In this case, y x become 1. Oh, okay. Now, before these steps, what you move, you shift this plane to new thing, right? You shift to new slot here. Means it's better you go along the x-axis. You can use your origin here. You can use your origin here. When you rearrange the equation or the index later, you still get the same answer. But it's just another way of solving. Means it uses a new origin that along the x-axis. So you x move 1, then from this origin is actually move back to the left. So move back to the left is 1 over 15 over 5 over 12. Negative because move to the left. And then your z is infinity. You move along the z-axis. But if you old origin here, you still can find the same answer, right? X, but your y is from here to here, right? Your origin y is from here, move back, right? So you still get negative. Origin here, you move back to this position, you still get negative 5 over 12. Can. It depends on like how you see the question. Okay. Right. Then after that, you flip the number. Okay. This is position. Then you flip because you want to find the Miller things. So you flip the number. 1, you flip, you still get 1. And then this one, remember, it's still negative. You flip, you still get negative. But you flip 5 become below, 12 become top. Infinity, you flip, you get 0. You flip infinity, get 0. So this is the once you do, and then we don't want the fraction, right? So you remove the fraction. Okay, you remove fraction, multiply by 5. So 5 minus 12 and 0. This is the final answer. This is a Miller indexes. Okay, so these are the way you do it. So another example. So example 7, you're given coordinate with comma, 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 right? So you have 3 coordinates. Again, the step also same. You draw the cube, mark your origin at the corner there. Then you put in the 3 value there. So once you 3 value there, right? So like that, a bit complex, but you should able to draw. So the first one is over here, 1 over 4 here. C, and this one is 1 half, 1 half here. This one 1 over 3 here, 1 over 4 here. And all coordinates axis. Yeah. So you are given the 3 coordinates. Okay, you locate ABC first from the question. Then you need to find D. Okay. Now, how to find D? In your mathematics, there is an equation that you are given 2 known coordinate. You can predict the third coordinate. There's a mathematics chapter inside 3-dimensional Cartesian plane. So there's a step lah. So if you forget, then go ask Google how to predict the third location from 2 coordinate. There's one particular equation to do that. Okay. So then you use the mathematic predict this one. Then you draw the line connecting that one.
If I know how to predict by drawing, but then cannot give you the coordinate.
If you guess the right number, I will give you marks.
So not need calculation lah. Important is
If you like, you can write the right number
I
here.
can imagine the right position and roughly write the number,
Then I'll give you correct lah.
okay.
Important, because important the question is to test you the Miller index, is not test you on the next part. There's a way lah, you better show it lah. Better show it. Okay, there's a video there, go and watch how to, I even put in my slides. Go and click the YouTube there. Okay. So there's a 12 minutes things. Therefore, I go home read. Okay. So there's you go to YouTube, this one, then you go and watch 2 minutes video. Okay. So basically you do prediction of the third. Okay, this one I skip. But I want you to learn about the procedure or the principle solving this one. So basically you get the 3 point, then you predict the third point, you connect the thing, then you get a plane like that. So important, what is more important is actually the B is not on the axis. The B point is not on the axis, is this point on the axis. So A, C, and D will actually help you to do the calculation. So this example 7, actually there's a additional steps where you need to predict the third steps that landed on the axis. Landed on axis where you get one number is 0. One of it you get 0. Okay. So there's a procedure there. So once we get it, axial plane ACD landed at x minus half. Yeah. Axial z half. Y z is half. Okay, so this plane ACD, it will intercept at axis. So you move your origin to the one corner. So then you're able to see the intercept from this origin. Of course, you can do from here if you want, right? But it's better you choose one of the corner. And have it. Of course, again, you can do this from here. It's the same. So this question or this answer, it dropped the origin, change from here to point E. So how many steps it moved to this one is move half, minus half, it move back in x-axis. Then Y, it also move back a bit, right? It move back minus quarter 4, three quarter. Then Z is also move up into 1. Then you do reciprocal, you convert the things. Because this is coordinate, like not coordinate, it's like indexes. Then you flip. This one you flip, get -2, flip this one, get 4/3, flip this one, you get 2. But again, Miller, we don't like fraction. Remove the fraction, multiply by 3. So you get this one. Okay, so the catchy part or the difficult part is the prediction of the third point. So this one, you go and watch the video lah. Okay, but the important is you know the steps, how you solve the problem, this kind of problem. The concept of this one, even though the question give you 3 dot, maybe one of dot is not what you want to use. You have to predict this one landed on the axis, means either one of these becomes 0. So this one, it landed here. So your Z will be 0. Right? If it landed, you predict this one, landed on the flat surface here, it will be 0, right? Or you catch the point C, the point C is landed on the Z-axis. So what you do, you catch another prediction point at Z-axis. Okay, then how you get half and 1, this one you go and watch the video. You substitute the value inside the formula. This one? This one, this one, right? Okay. This one you get from the origin. The new origin means once you get the plane, you can either from the origin or you move to the one of the corner. In this case, the question choose this point E, new one. So how you write this one? From this point to the x-axis. So this is x ma. So from this point along x-axis. So it move to the front or move to the back. Move back ma. From here move back ma. Here to here not move back ma. Here to here. E to D. Move back ma. So negative oh. Negative half oh. Because this length is half ma. Y. Here to here. This is Y ma. So this point to Y. So how long it moved from here to here? It moved to the left or right? Left ma. Left negative oh. Negative 1/4 lo. Yeah. Sorry. 3 1 3/4. Okay. Because here to here is 1/4 ma. Here to here is 3/4. Z. Here move up here. What's the length here? Half ma. Because we need to find the location for 3 coordinate that landed on the x, y, z axis. This is z axis, this is y axis, this is x axis. So once you get these 3 points, you flip the number. You flip the number to find the Miller plane numbers.
Oh.
So this one you flip, you get the final Miller index plane.
Okay, I get what you mean by the same.
Yes. Yes. So all the example they give you how like we going to test you. You just need to be smart enough to see how it form. But always remember there's a flip process. Either from Miller flip back to here or from the intercept flip back to plane. Same. You always need to flip the thing. But always remember that the intercept always at the x, y, and z axis. Okay. Okay, so this is another one on the plane. So this one is the application of KL. Remember to memorize this equation. This one will give you 1 marks, and from here you substitute the value of H, K, and L. So here H, K, and L was given D220. So 220. Okay. A was given, and in nanometer, so you just substitute and you get the answer. Okay. Test will be more on all these very simple one. That's one. And then final one will be incorporate this one with another chapter. It's an application of this one. Application will be more in the you do the alloying. Later you will look at what is the space between the two and how you fit in the numbers and so on. That one is a combination in one question. Okay, we stop for a while. Okay. We continue 5:05. 5:05. Have a break.